So in this concept, we're going to talk about solving a system of equations with the elimination method. Okay, so we talked about the graphing method, the substitution method, and now we're going to talk about the elimination method. So here's an example. Solve by using the elimination method. This is a system of two equations, x minus y equals 5 and x plus y equals 9. So the basic principle behind the elimination method is that you should look for you basically need to add or subtract both equations such that you can eliminate, again, hint from the name, you can eliminate one of the variables, and then you end up with the other variable, and then you solve for that variable. Then you can go back and plug in that variable into either of the original equations to find the other variable that was eliminated. Okay, let's look at how this works. So here, since we have, x and then minus y and plus y, you can see that if I added both of these equations, the y's would actually go away, right? The y's would actually be eliminated. They would cancel out. Okay, so if we added both equations, we get, so x plus x gives me 2x, minus y plus y gives me 0, so y was eliminated. 5 plus 9 gives me 14. So now I have a new equation, 2x equals 14. I can solve for x by dividing by 2, each side by 2, to get x equals 7. So now I just basically solved for x in this system of two equations. Now I can take the x and substitute back into any of the given equations. Okay, let's just pick equation 2. X plus y equals 9. So with x being 7, so 7 plus y equals 9, y is 9 minus 7, or y equals 2. So now my solution is 7 and 2. Okay, let's look at another example. 3x plus 1/2 y equals 9, x minus 1/3 y equals 6. In this case, we would like to, so for example, if we attempted to eliminate the y's, we would be working with fractions, and it would be a little not as straightforward as working with the whole numbers. So let's try to work with the x. So eliminate the x's, not the y's, okay, to avoid having to add the fractions. So again, this is all a matter of choice. We could choose to eliminate the y's and, add up the fractions, but it would just take more steps. So to make the x's additive inverses in both equations, we can multiply equation 2 by minus 3. Again, this is just, one's choice. I mean, you can choose otherwise, but this, in this case, would be a reasonable choice to make. We choose to multiply this second equation by minus 3, which gives us minus 3x plus y, right? We get rid of the minus 1/3, equals minus 18. Okay, so 6 times minus 3 is minus 18. Now we can add both equations to each other. So 3x plus 1/2 y equals 9, minus 3x plus y equals minus 18. So now the x's cancel out, right? 3x minus 3x is 0. 1/2 y plus y is 1.5 y, equals 9 minus 18 is minus 9. We can convert the 1.5 to an improper fraction. Again, this makes it easy to, get rid of the fraction, move it from one side to the other. So 1.5 is essentially 3/2, right? In this case, we want to isolate the y, so we multiply both sides by 2/3, right? 2/3 times 2/3, so these cancel out. And then minus 9 times 2/3, so divided by 3 is 1, divided by 3 is 3, so minus 3 times 2 is minus 6. So y equals minus 6. Now we can take that minus 6, that y equals minus 6, and plug it into either of the original equations. Remember, these are the two original equations up here. right? Find up here. 3x plus 1/2 y equals 9. X minus 1/3 y equals 6. So let's plug into the first equation. 3x plus 1/2 y equals 9. Plug in y is -6. So we get 3x plus 1/2 of -6 equals 9. 3x minus 3 equals 9. 3x equals 12. X equals 4. So my solution is 4 and -6. Okay? Here we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay, so solve the system of equations by elimination. So 2x minus y equals 15 and 3x plus y equals 20. So right then and there we see that here we have the y's, with their coefficients as additive inverses. So if we simply added these two equations together, we're going to get rid of the y, right? So we would get 2x plus 3x, which is 5x, and then plus y minus y, that cancels out. And then 15 plus 20 is 35. So 5x equals 35, so x equals 35 over 5. So x equals 7. Okay, that's my x. Now I can plug it into either equation. Let's plug into the first equation. So 2x minus, so this would be 2 times, actually let's plug into the second equation, to avoid the negative sign. Again, it's a matter of choice, choose whatever is easier for you. You can plug into either equation. So 3 times, now the x is equal to 7, so 3 times 7 plus y equal 20. So 3 times 7 is 21, plus y equals 20, so subtract 21 from both sides, right? So y equals 20 minus 21, so y equals minus 1. Okay, so my solution set is 7 and minus 1. Okay, let's look at the second exercise. So here we have minus 4, minus 4x minus 1/2 y equals 1/2, and 1/2 x plus y equals 1/4. So what we could do is, if we multiply the first equation, you can make whatever choice you want. The goal is to just make it simpler, right? Not have to add as many fractions in this case, because we have, multiple coefficients that are fractions. So let's just, multiply the first equation by 2. What do we get? We get minus 8x minus y equals 1. So that looks much nicer, right? With the second equation, which is 1/2 x plus y equals 1/4. Now look at that, right? So now we have the y's as additive inverses. So if we just added these two equations, right, the y's would cancel out. So we would get minus 8x plus 1/2 x is minus 7 and 1/2 x equals 1 and 1/4, right? So we can convert these to, let's work back here so we have more space. So minus 7.5 is minus 15 over 2x equals 5/4. Okay, so if we multiply both sides by minus 2/15, times minus 2/15, right? These two will cancel out. So x will equal, so divided by 2 is 1, divided by 2 is 2, divided by 5 is 1, divided by 5 is 3. So we have minus 1 over 6. So x is minus 1/6. Okay? And then what we can simply do is plug this into either equation to solve for y. So, for example, we can plug into the second equation, right? So 1/2 x plus y equals 1/4. So 1/2 of minus 1/6 plus y equals 1/4. So 2 times 6 is 1 over 12. So minus 1 over 12 plus y equals 1/4. So y equals 1/4 plus 1 over 12. We can take, a common denominator, right? So we can make this, so 1/4 is 3 over 12, right? So we get 4 over 12, or divided by 4 is 1, divided by 4 is 3, so y equals 1/3. Okay, so my solution set is minus 1/6 and 1/3. Okay, this is it for this video. See you in the next concept.